Dear students, we have reached or come to the end of the series of classes on the chapter Calculus Recapitulation. And this is the last and fifth class. And in this class, we will learn how to plot curves and then Taylor and binomial series. And before, first of all, we need to know how to plot a curve. And in our first, at the initial class, or the first class, we have learned how to plot a graph. And in that case, and in the present case, that is in this class, we learn how to plot a curve. Obviously, in that case, we have to keep in mind different type of informations and depending on which we can plot a curve. So students, let us start from from the plotting of curves. So to do this, so suppose that we have given a function y is equal to fx, and using the knowledge of calculus and the properties of the given curve, you can plot that curve on a graph. So, but before plotting this or plotting of a curve on your on the graph, you have to remember or you have to adopt the following following topics or following informations. Number one is the domain and range of the curve are to be found out. So first, from the knowledge of your calculus, the knowledge of calculus, and from the given function that will be given to you, and you have to first find out the range of the curve, domain and range of the curve. Then the points of intersections of the curves with the coordinate axis are to be find out. That means the intersection on the x-axis or the intersections or intercepts on the y-axis are to be calculated. And in case of the intercepts on the x-axis, in that case y should be 0. So in this case y should be 0, but x should have some definite values. In the similar way, for the intercepts on the y-axis, you can easily or can comfortably use x is equal to 0, but y will have some definite value. Thus, the intercepting in this way, the intercepts or intercepting points on the x and y axis can be calculated in this way. Number three is check if the curve is symmetric. That is, you have to check the curve whether the curve is symmetric or not. Number one is that if fxy that is equal to fx minus y, that is in this case if you replace y by minus 1 and the function remains the same, then the curve is said to be symmetric about x-axis. Okay, that means it has identical shape above and below the x-axis. That is shown here. See here, it has the same value, identical above and below the x-axis. That is in this case y is positive here plus, and in this case y is minus y. So, however, if we change the value of y by minus 1 minus y, then the function will have the same value. Then it is said to it will be said that the function is symmetric about x-axis. The similar thing has is happened in case of this type of function, that is fx. If fx is equal to f of minus x y, in that case the function is said to be symmetric about the y-axis, because in this case here is x is positive, here is x is negative, but both functions are identical, for which x is replaced by minus x. Another one is there. Next one is there. If fxy is equal to minus x minus y, since in this case both x and y are replaced, then the curve is said to then the curve is about the origin. Then the curve is said to be symmetric about the origin. So in that case, curve has the identical shape in the first and the third quadrants. That means in the first quadrant is here both x and y are positive, and in the third quadrant here is that in this case both x and y are negative. So here, and in this quadrant, it has the function has an identical value. So when fxy is equal to minus x minus y, then it is said that the function is symmetric about the origin, and the function will have the identical value in the first and the third quadrant. Now the next one is, if fxy is equal to fyx, then the curves is symmetric about the line y is equal to x. So y is equal to x. So in this case, so this is another point, that in that point, that if fxy, that in this case x is replaced by y. So x is replaced by so in this case, if x is replaced by y, and that means in the similar way y is replaced by x, and the same thing, and in that case the same curve is said to be symmetric about the line y is equal to x. In similar way, if fx is equal to minus f of minus y minus x, in that case it will be said that the curve is symmetric about the axis y is equal to minus, about the line y is equal to minus x. And another point is here, if fx is equal to fx plus t, then the curve is said to be periodic with a periodicity of t. Okay, thus the curve can be plotted in any interval and can be extended on either side to its periodicity. And number 5 is, next come to number 5. Asymptotes to the curves are found to be found out, and the asymptotes parallel to x-axis are found out by equating the highest power of x to 0. In the similar way, the asymptotes parallel to y-axis is found out by equating the highest power of y to 0. So to check or to find out or to test the asymptotes, to find out the asymptotes parallel to x and y-axis, you have to just equate. For x-axis you have to equate, for parallel to x-axis you have to equate the highest power of x with to 0, and for parallel to y-axis the highest power of y to 0. So in this way you can identify the asymptotes, is whether the asymptotes is parallel to x-axis or y-axis, if there be any asymptotes. The inclined or the oblique of asymptotes of the curve are given by y is equal to mx plus b, and here tangent m is equal to limit x tends to infinity y by x, and b is equal to limit x tends to infinity y minus mx. From this relation, b is this. So asymptotes not parallel to x and y axis. This These are the conditions. These are the ways. Now critical points, and these critical points are very important, because using or finding out, if you once able to find out the critical points, you can understand whether there is any maxima or minima on the curve. So critical points, that is the points of maxima and minima, and should have to find out. And if we have given function y, and then just differentiate it with respect to x, and if dy by dx is greater than 0 in the interval ab, then the curve is increasing in this interval. And on the conversely, if dy by dx is less than 0, then the curve is decreasing in this interval, that is the given interval ab. Okay, the intervals in which the curve is concave upward or concave downwards are found out. So you have to test whether the concavity of the curve, that is whether it is upward concave or it is downward concave, and the intervals at those intervals where the curve is concave upward or concave downward, that should be also found out. And at a point at which d2y by dx is equal to 0 is called an inflection point. So if you calculate, find out the value of d2y by dx square, and if it is 0, then for certain value of x it is 0, and that point is said to be the point of inflection. And at this point, the concavity, that is at this point the concavity of the curve changes from downward to upward or upward to downward. Okay, that is, it is inverted in this case. So we learn much more informations in these sections, that is to plot a function or a function of a curve. So it is so don't be scared of this, because you need not to check all these things to plot a curve, but some uh, there are some definite methods, definite techniques, or definite things to be found out to plot a curve. And this is the basic ideas or basic things we have to do in plotting a curve on a graph. But it need not to remember all these things, but only from the knowledge of fewer terms, fewer things, you can plot the curve on a graph. So we are doing here, just carefully see the example. And the first example is sketch the graph of the curve y is equal to x minus 3 into x minus 7 by x squared. So here the given function is fx is equal to x minus 3 into x minus 7 by x squared. So now if you use the value x is equal to 0, then y is equal to fx, this function is not defined, will not be defined. So it is not finite, but except x equal to 0 for all values of x, and the given function is defined, that is, it has finite value. And now, first of all, you have to find out the intercepts. So you know that you have the curves can intercept y-axis as well as the x-axis. If for the case of intersection on the x-axis, so in that case, if y should be 0, so in this expression, just look at this expression. In this expression, write y is equal to 0. And if then you calculate the values of x, then that will be that values of x will be the intercept on the x-axis. So let us do it. X minus 3, x minus 7 into x square is equal to 0, or from here x is equal to 3 and x is equal to 7. So 2 points for x is equal to 3 and 7, the curve will intercept with the x-axis. Obviously, keep in mind that y is equal to 0 in this case. So the point of the coordinate of the point of interceptions are 3, 0 and 7, 0, because y is 0 in this case. So now find out the value of maxima and minima. So you have given the function, that is this, just this x minus 3 into x minus 7 by x squared. Simplify it, it will this give this, and find that from that you will have this, and finally y is equal to 1 minus 10 by x plus 21 by x squared. So from here dy by dx is equal to you are finding out the values of dy by dx. That is, from here first term is 0, then minus 10, 1 by minus 1 by x squared, then plus 21 into minus 2 by x cube. So dy by dx is equal to 10 by x squared minus 42 by x cube. Now at the critical point, you know that dy by dx is equal to 0. So just equate this is equal to 0, and then calculate for x. X is equal to 4.2. It is calculated as 4.2. So the value of x is equal to 4.2 at the critical point. Now we are here to find out the value of d2y by dx square. So the value of d2y by dx square is here from the first term, minus 20 by x cube, then from this term minus 42 into minus 3 into x to the power 4. That means it will give you minus 20 by minus 20 by, here is calculated. So minus 20 by x cube plus 126 by x to the power 4. Now just calculate the value of d2y by dx square at x is equal to 4.2. That is done here. And it is easily understandable from here that 126 minus 20 into 4.8. Okay. And that should be a positive quantity, because this is the higher, this term is higher than this. So this is a positive quantity. What may be its value? It be a positive quantity. So d2y by dx square is greater than 0. That means at x equal to 4.2, the curve has minima. that means the curve is minimum at x equal to 4.2. The minimum, now the minimum value, you are here to find out the minimum value. So y minimum is equal to, just use the value of x equal to 4.2 in this relation. That is y, in this relation y is 1 minus 10 by x plus 21 by x square. Just use the value of x is equal to 4.2. That is done here, and finally you obtain y minimum is equal to minus 0.19, minus 0.19. So again, using d2y by dx is equal to 0, we can write, since you have obtained d2y by dx is equal to this. So this is equal to 0. That means from here you have calculated x is equal to 63 by 10. That means 6.3. So y for now, you have to calculate y for x is equal to 6.3. So now use the value of ax as 6.3 in the expression of y, that is 1 minus 10 by x then plus 21 by x square. In this relation, you have obtained that y is equal to minus 0.6. So the point 6.3, here x was 6.3, and from here y is minus 0.6. This is the point of inflection. Okay, this is the point of inflection. Now just find out the value of limit y x tends to 0 yx. That is equal to limit x tends to 0 x minus 3 by x into x minus 7 by x square. That is equal to infinity. Just when you use the value of x tends to x is equal to 0, then it will provide you a value infinity. So then x equal to 0 is a vertical asymptotes. So x equal to 0 will be a vertical asymptotes, and limit, if you use the value of x tends to infinity, the limit of yx at x tends to infinity, then you can find out that this has the value 1. So y is equal to 1 is the horizontal asymptotes, and the graph is plotted here. This is the asymptotes, which is parallel to, which is x equal to 0 here. So x equal to 0 is asymptotes. Another asymptotes is y is equal to 1. That is here, and the graph is here. And this point is the point of inflection, that is here 6.3 and minus 0.01, and the point of intersections are 70, it is here, and it is 30. And you also know that this is actually the graph. Okay, so depending on the values of that we calculated here, the graph is plotted here. This is the graph. Now plot of the curve of the function yx cube minus 12x minus 16. So just factorize this. The technique or process of the factorization is here. So y is finally, we obtain x plus 2, then x minus 4. So yx can be written as x plus 2 whole square into x minus 4. Then y of minus x should be here. Just x is it is replaced by minus x. Then it is found out this value. So yx is this and y of minus x of this. So these two values are not equal. So y is not symmetric. Now intercept on the x-axis. So in this case y equal to 0, you know. Then this value x plus 2 square into x minus 4 is equal to 0. From here x is equal to minus 2 and x is equal to 4. And you know that in this case y is equal to 0, the point of intersection, okay, the point of intersection will be minus 2 0 and 4 0. And for the value of x is equal to 0, now for the case of the intercept on the y-axis, you know that in this case x becomes 0. So using the value of x equal to 0 in this expression, I will finally obtain that y is equal to minus 16. From this relation equation number 1, it will be very easier to calculate. So the point of intersection on the y-axis is 0 minus 16. So minus 2 0 4 0, these are the interceptions on the x-axis, and 0 minus 16 is the interceptions on the y-axis, intercepts. Now maximum and minimum, given the function is given y is equal to this, then find out the value of dy by dx. 3x square minus 12, that is 3 into x square minus 4. So the vertical points are obtained by so the critical points, the critical points are obtained by writing or putting dy by dx is equal to 0. That means this is equal to 0. From here x is equal to plus minus 2. So you obtain x is equal to plus minus 2. Now once again differentiate this expression with respect to x, then that will provide you d2y by dx square, that is equal to 6x. Now use the value of x is equal to 2 for determining the value of d2y by dx square. That will provide you 12, which is greater than 0. So at x equal to 2, the point is and x equal to 2 is the point of minimum. And now similarly d2y by dx square for x equal to minus 2 is calculated as minus 12, that is less than 0. So x equal to minus 2 is the point of maximum. So so x is equal to minus 2, here see here is the minimum and x is equal to 2 is the maximum. So okay, the curve has the maximum value. So y max, now find out the value of y max. So y max is equal to maximum value of y, just use the value x is equal to minus 2 in the expression. In which expression? That is in this expression. So after doing that, you obtain that the y maximum value is 0. So the points of inflection is obtained by writing d2y by dx is equal to 0, or from here dx is equal to 0 or x is equal to 0, and for x is equal to 0, from the given expression y is equal to minus 16. So point of inflection is 0 minus 16. 0 minus 16. So curve is drawn here. See here the point of intersections are 4 0 and 2 0. So this point and this point, and the point of inflection is this 0 minus 16. So you have to just connect, and this is the point of inflection. That means this part and this part will be identical, and since it is minus 16, so this part will be another minus 16, because this height is minus 16, so this height should be another minus 16, so this will be minus 32. And since it is minus 2 in this coordinate, so in this quadrants, so in this quadrants it should be plus 2. So this point should be 2 minus 32. So this is the graph that we have plotted here. Next one is plot the graph of the function x square minus 3x minus 4, that is equal to y. So y is here this, so just factorize it. You have obtained this. Now the point of intercepts, that in that case y on the x-axis. For the point of intercepts on the x-axis, the y should be 0. So this should be 0, and from here you obtain x is equal to minus 1 and x is equal to plus 4. So the point of intercepts on the x-axis are minus 1 0 and 4 0. And similarly the point of intercepts on the y-axis, in this case x becomes 0. So using from this expression y is equal to minus 4. So the intercepts on the y-axis is 0 minus 4. Therefore we can summarize here that the curve intercepts the x-axis at minus 1 0 and 4 0, and the y-axis at 0 minus 4. Now we have to find out the maxima and minima from equation 1, that is given here. Equation number 1 is y is equal to x square minus 3x minus 4. From here you can calculate dy by dx as 2x minus 3, and for critical point you know that dy by dx is equal to 0, and from here 2x minus 3 is 0, or x is equal to 3 by 2, that means 1.5. So y at x is equal to 3 by 2, you have to find out the value of y by using the expression, that is this expression, x square minus y is equal to x square minus 3x minus 4. So that is done here. So y is equal to, or you can use this factorization term, that is this one also, y is equal to x plus 1 into x minus 3. So doing that, you obtain y is equal to minus 25 by 4. So this also d2y by dx square is equal to 2, that is greater than, so d2y by dx square, just differentiate this, d2y by dx square is equal to 2, that is greater than 0. So y has a minimum value at x equal to 2. So no, d2y by dx since it is equal to 2, that is greater than 0, so y has minimum value. So now we have to plot this graph. Here is that the point of intersections are minus 1 0, this is 1, and the other one is 4 zeros. So this point and this point should be joined or should be joined. Okay. Now the point of the point of intersection on the y-axis was 0 minus 4. So just just connect this. So this will be the graph that you have to find out. And obviously, in this case, you can also find out the point of inflection by the knowledge of the previous calculations. You have to find, you can calculate the point of intersection inflection, and you will then able to completely plot the graph. Now Taylor series. Now come to the next point, that is Taylor series. And this is very important in mathematics because in sometimes and physics also, because in sometimes we have to expand a function or a number, especially a function, into its into series. And in that cases, Taylor series and as well as binomial expansion also will be very helpful. And Taylor series is very important in the sense that using Taylor series, a function can be expanded in series. So let us see what is the Taylor series. If you have a given function, that is fx, and it is defined that it has finite values in all finite, the value of fx is finite for all values of x, and it has continuous derivatives in some interval around x is equal to a. Then the Taylor series expansion of fx about the point x equal to a is given by fx is equal to fa plus x minus a by 1 factorial f prime a plus x minus a whole square by 2 factorial f double prime a plus in this way x minus a to the power n by n factorial f n prime a. So to expand a function into series, we have to first have the information about the value of the fx. So if fx is defined that it has finite values for all values of x, and it has continuous derivatives. You have given a function x is equal to a. If it has continuous derivative about the point x is equal to a, then you can expand the function fx in series using Taylor series expansion, and that is written in this expression. And if in this expression you write or you substitute x a is equal to 0, then this series actually converts into Maclaurin series. So the Maclaurin series can be obtained by using a is equal to 0 in the Taylor series expansion. So fx is equal to f0, then x minus a means x by 1 factorial f prime 0 plus x square by 2 factorial f double prime 0. In this way, x to the n by n factorial f n prime 0. So this is essentially Maclaurin series, and this series can be obtained from the Taylor series expansion using a is equal to 0. So Maclaurin series actually special series expansion of Taylor series for which a is taken as 0. Now come to the binomial series. If fx has the form 1 plus x to the power m, then its binomial series expansion has the form if x is equal to 1 plus x to the power m, that is equal to 1 plus mx plus am into m minus 1 by 2 factorial x square. And then the next term is am into m minus 1 into m minus 2 by 3 factorial into x to the x cube. In this way we can proceed, and then you can write this term as, since this is for the kth term. So in this case it was the third term. So this has the values am into m minus 1 m minus 2, that is this term is nothing but am minus this value 3 then plus 1. So if this is taken as k, so the last term, the k term would be m minus k plus 1 by k factorial x to the power k. So that can be written as 1 plus this one is there, sum over k is equal to 1 m into m minus 1. In this way, m minus k plus 1 into x to the power k by k factorial, where f mod x is less than 1. So examples are here. Find the Taylor series expansion of fx, that is equal to sine x about x is equal to pi by 2. So you know that the Taylor series expansion of fx uh, sin x about x is equal to pi by 2 about the point x is equal to pi by 2 can be given as fx is equal to f of that value x. You know the formula was fx is equal to f x at the value at about which you are uh, finding out the expansion of the function. So the formula was fx, that is equal to fa plus x minus a by 1 factorial a prime a, then x minus a square by 2 factorial a double prime a. In this way, x minus a to the power n by n factorial fn prime a. So we are doing that. We are here. We can write fx is equal to since it is doing about the point x is equal to pi by 2. So fx is equal to f of pi by 2, then plus x minus pi by 2 by 1 factorial f prime pi by 2, then plus x minus pi by 2 square by 2 factorial f double prime pi by 2, then plus x minus pi by 2 cube by 3 factorial f3 prime pi by 2. In this way, x minus pi by 2 to the power n factorial f n prime pi by 2 plus etc. So now we have to find out these values f pi by 2, f prime pi by 2, f double prime pi by 2, etc. So here is the function fx is equal to sin x. So from here, if you use the value of x is equal to pi by 2, then f pi by 2 is equal to 1. Thus, f prime x from this relation, f prime x is equal to cos x, f double prime x is equal to differentiation of this is minus sin x, f triple prime x is equal to minus cos x, f 4 prime x is equal to sin x, and so on. Now use the value of x equal to pi by 2, f prime pi by 2 will be 0, f double prime pi by 2 will be minus 1, f triple prime pi by 2 will be 0, and f 4 prime pi by 2 will be 1. Now just substitute these values f pi by 2, f pi by f prime pi by 2, f double prime pi by 2, these values in this expression. Just doing that, just substituting these values, we obtained the first term is 1, that is 1. Then since it is 0, so 0 is here. Then minus 1 is here, so minus 1 is here. X minus pi by 2 factorial there from this part. Then plus 0 for this term. Then the next term will be x minus pi by 2 to the power 4 by 4 factorial into 1, and then the very next term will be 0, and in this way this term will be x minus pi by 2 to the power n by n factorial, and depending upon the value of n, if it is n is even, then it should be 1, and if n is odd, then it should be 0. So however, we can proceed after these plus dot 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 etc. So fx is equal to 1 minus 1 by 2 x minus pi by 2 square from this term by 2 here, from this term x minus pi by 2 by 4 factorial, from this term minus x minus pi by 2 to the 4 by 6 factorial. So this is the expansion of sin x about the point x is equal to pi by 2 plus dot etc. This is sufficient in this term. Okay. So now apply the series expansion of fx is equal to the power x about x equal to 0. So the point is given is 0. So now fx is equal to the power x, so f prime x is equal to the power x. So f prime x is equal to 0, and then f double prime x is equal to e to the power x. That means f double prime x uh, at x is equal to 0 is equal to 1. In this way, f triple prime 0 is equal to 1, and so on, and obviously f 0 is equal to 1. So now the Taylor series expansion of fx is given by, you know that fx is equal to f about, since the point is 0 here, we are here to expand Taylor series expansion of fx about the point x equal to 0. So fx can be written as f of 0, then plus x minus 0 by 1 factorial f prime 0, plus x minus 0 square by 2 factorial f double prime 0, plus x minus 0 cube by 3 factorial into f triple prime 0. In this way, in this way it will proceed, it will continue. So plus etc. dot 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 etc. So for first term, if 0 is equal to 1, then this term x by 1 factorial into a prime 0 is 1, then plus x square by 2 factorial into 1 plus x cube by 3 factorial plus 1. In this way, xn plus factorial plus etc. So e to the power x is equal to, can be written as 1 plus x square by 2 factorial x cube by 3 factorial, denoted in this way is xn by n factorial. So this is the expansion of e to the power x in Taylor series. Now another one is that obtain the third degree Taylor's polynomial approximation of fx is equal to root x about the point 1, x is equal to 1, such that x 1 less than equal to x less than 1.5. So in this case, you have to find out the expansion up to the third term. Okay, and the function is given as fx is equal to root square root x, that is x to the half. So and you have to expand this function about the point x is equal to 1. So just find out the value of f1. So f1 can be calculated from this relation. F1 is equal to 1. Now you have to calculate f prime 1. So f prime 1 is here. F prime 1 is equal to, just calculate here. This is equal to minus 1 by 4 x to the minus 3 by 2. Now at the value of x equal to 1, if prime 1 is equal to, calculated as minus 1 by 4, that is here. Sorry, yeah, that is here, half, that is here half. Sorry, f prime x is equal to half x to the minus half. So here f prime 1 is equal to half, and this is the f double prime x. So that is double prime 1 is will be minus 1 by 4, and in the similar way triple prime x is equal to this, and from here f triple prime 1 is equal to this. So this 3 by 8, 3 by 8. Okay, so now the Taylor series expansion of the function fx, okay, about the point x equal to a, can be written as fx is equal to f1 then plus x minus 1 by 1 factorial f prime 1, then plus x minus 1 square by 2 factorial, then into f double prime 1 plus x minus 1 cube by 3 factorial into f triple prime 1, because you have, the condition was given that you have to approximate these polynomial using Taylor series up to third degree. Okay, so we have taken it as up to third degree, and less, and the rest part are not taken here. So from here just simplify 1, then x minus 1 into half, then x minus 1 square by 2 factorial, then minus 1 by into minus 1 by 4, and this. Okay, so finally 1 plus x minus 1 by 2 minus x minus 1 whole square by here 8, then plus x minus 1 cube by 16, so on. So now another one is here. So the next example is to use the binomial expansion. You have to find out the value of 1 by x using binomial expansion, and you know that the binomial expansion of 1 plus x to the m is, it can be written as 1 plus mx plus m into m minus 1 by 2 factorial x square plus etc. plus m into m minus 1 dot m minus k plus 1 by k factorial into x to the k plus etc. So here just compare here this function with your given function 1 by 1 plus x, that is, it is nothing but 1 plus x to the power minus 1. So m is in this case minus 1. So just substitute the value m is minus 1 in this expression. Then you can easily find out the binomial expansion of 1 plus x to the power minus 1, that is 1 by 1 plus x. So doing that, we have obtained just here the substitution method is given here, and finally here the term we obtained as 1 plus x to the power minus 1, that is equal to 1 minus x plus x square minus x cube plus x 4 plus etc. So the given function 1 by the binomial expansion of the given function 1 by 1 plus x is equal to 1 minus x plus x square minus x cube plus x 4 plus all other terms. Now another one is here binomial expansion. We have to find out the binomial expansion of 1 by 1 plus x. So square root 1 plus x. So the function is given here 1 by root over 1 plus x, that is 1 plus x to the minus half. And you know that the binomial expansion of the function 1 plus x to the power m is given by that is given by 1 plus mx plus m into m minus 1 square by 2 factorial plus m into m minus 1 m minus 2 3 factorial into x cube plus in this way m into the next term will be m into m minus 1 m minus 2 m minus 3 by 4 factorial into x to the 4. In our case, in our present case, m is equal to minus half. This fx is nothing but 1 plus x to the power. Okay, in this case, but in this case m is equal to minus half, so just substitute the value of m is minus half in this expression. That is done here, and you obtain one that if x is equal to 1 minus half x plus 1 into 3 by 2 square 2 factorial x square, then 1 minus 3 1 minus 1 into 3 into 5 2 cube 3 factorial, and then plus 1 into 3 into 5 into 7 by 2 to the 4 into 4 factorial into x to the 4 and so on. So the binomial expansion of the function 1 by square root 1 plus x, that is equal to 1 plus x to the minus half, is given here, just written here. So we here we able to find out the value of a function using binomial expansion and Taylor series expansion. And here are some examples. Here are some standard expansion of some functions: sin x, cos x, sin hyperbole x, cos hyperbole x, tan x, e to the power x. Already it is calculated. Already cos x, sin x has been calculated. Then log 1 plus x, log 1 minus x, tan inverse x, 1 plus x to the power n. So these are the important functions and their expansions, and you can practice in your own using Taylor series expansion. So I will suggest you to practice all the mathematical deductions, all the mathematical calculations, and if you do it your own, or if you do yourself, then everything will be very interesting. So students, this is the end of this class and hence this chapter also.